Hi, this is Shirisha. I implemented the skipgram with negative sampling SGNS model, the core training approach behind WAD 2 vectors, completely from scratch using NumPy. The goal was to understand how WAD 2 vectors learns meaningful WAD embeddings efficiently without using automatic differentiation or high-level deep learning frameworks. This project covers implementing skipgram with negative sampling from scratch using pure NumPy, implementing the 3 by 4 power unigram negative sampling distribution, building a negative sampling lookup table, implementing frequent word subsampling using the standard discard probability, implementing a dynamic context window with randomly shrunk window sizes, implementing a linear decaying learning rate, manually deriving and coding the gradients, verifying the analytical gradients using finite difference gradient checking, training on at least 10 million tokens, using embedding dimensions between 100 and 300, using 5 negative samples as the main experiment. Scriptgram objective was for a target word W, context word C. The objectives is log sigma use C transpose VW plus sigma log sigma minus U R transpose VW, where UW is target word embedding, UC is equal to positive context embedding, and UR negative sampling embedding, and sigma function. The objective encourages the target and real context words to have high similarity while pushing randomly selected negative words away. Gradient verification is the gradients of the skipgram negative sampling objectives are derived and implemented manually. To verify the implementation, a finite difference numerical gradient check is performed. The analytical and numerical gradients are compared and the maximum relative error is reported. This provides an important correctness check before beginning large-scale training. Negative sampling. Negative words are selected using the 3 by 4 power unigram distribution. This prevents extremely frequent words from dominating the negative sampling process while still giving common words a higher probability of being sampled. A sampling table is used to make negative word selection efficient during training. Frequent word subsampling. Very frequent words are probabilistically discarded using the standard word 2 vector subsampling strategy. This reduces the number of uninformative training pace and can significantly improve training efficiency. It also gives relatively rare but informative words more influence during training. Dynamic context window. Instead of always using the maximum context window, a random window size is selected for each target word. For example, if the minimum maximum window size is 5, the actual window may randomly be 1, 2, 3, 4, or 5. This creates a variety of training examples and follow the original word to vectors training strategy more closely. The learning rate is gradually reduced during training. A linear learning rate decay is used so that early training makes larger updates, later training makes smaller, more stable updates. This helps the model converge without keeping the initial learning rate throughout the entire training process. The effect of negative samplings 2, 5, 10, 20 negative samples for each setting, both training time and nearest neighbor quality are evaluated. Generally, increasing the number of negative samples gives the model more negative examples per training pair, which can improve the quality of the learned representation, but it also increases the competition. Thank you.